Good morning everyone, it's me Arjun Pokhrel, science teacher of Sagarmatha Secondary School. Welcome to you all in my another online class. Here in the slide I have shown two diagrams. One is the diagram of the beam balance and another is the diagram of the spring balance. Okay, first one is the diagram of the beam balance. It is also known as the physical balance. This is known as beam balance or the physical balance, and this is known as spring balance. We know that beam balance is used to measure the mass of the body, and spring balance is used to measure the weight of the body. Okay, beam balance is used to measure the mass of the body, and spring balance is used to measure the weight of the body. In case of beam balance, one standard mass is taken in the one pan, and on another object which mass is going to be taken, okay, should be kept in the another pan. In this way we can measure the mass of the beam balance. But in case of spring balance, object is taken, okay, near the one end. Here metal bulb is taken at the one end of the spring balance, and it measures the weight of the object. Mass of the body is same all over the world, okay, but weight of the body is not same. It depends on mass and acceleration due to gravity. It depends on what? Mass and acceleration due to gravity. Now I am going to discuss about the topic that is mass. The amount of matter contained in a body is called mass. Total quantity of matter contained in a body. Amount of matter contained in a body. Okay, that is called mass. M-A-S-S, mass. It remains the same all over the world. Okay, when we measure the mass of the suppose potato, mass of apple in one part of our country, for example in the Chiton, and if we measure the mass of the same potato or the mass of the same apples, okay, in the another part of our country, for example in the Humla, in the Kathmandu, in the Sira, or anywhere, for example we can measure the mass of the same mass of the potatoes in the America, okay, it gives what? Same reading, but weight of the object is not same all over the world. It differs in the different part of the world. The mass of the body is measured by using physical balance or beam balance. This one is the physical balance or the beam balance, and it measures the mass of the body. Its SI unit is what? Kg, kilogram. Okay, SI unit of mass is what? Kilogram or kg. Mass of the body is measured by comparing the standard mass at one pan of the physical balance, okay, or the beam balance, and the substance to be weighted in the another pan. Okay, substance to be weighted in the another pan. Standard mass should be kept in the one pan of the beam balance. Okay, beam balance consists of two pan. Out of two pan, one pan is for in one pan we can put the mass of standard mass. Okay, in one pan we can put what? Standard mass, and in another pan we can put any substances, okay, to be weighted in the which is to be weighted in the another pan. Weight, the force with which it is attracted towards the center of the earth is called weight. Okay, the force with which it is attracted towards the center of the earth is known as weight. A spring balance measures the weight of the body. I already told you that spring balance is responsible to measure the weight of the body, and beam balance is responsible to measure the mass of the body. Its unit is Newton. It means weight of SI unit of weight is Newton, and in case of CGS system, its unit is dyne, dyne, dyne. Its value changes from place to place, and it depends on the value of acceleration due to gravity. We know the formula: weight W is equal to m into g. Okay, weight W is equal to what? M into g. It means weight depends on acceleration due to gravity. As the acceleration due to gravity changes, weight of the substance also changes. Okay, as the Dear students, I am going to discuss now another topic, that is variation of weight. Variation in the weight of the body due to change in the acceleration due to gravity. Variation in the weight of the body. We know that weight of the body is not constant all over the world. It changes in the different part of the world. Its value is not constant. First of all, change in the weight of the body due to change in the acceleration due to gravity. Change in the weight of the body due to change in acceleration due to gravity. As you know, weight W is equal to mg. Weight of the body is m is given by W is equal to mg. Okay, the weight of the body, the weight of a particular mass is directly proportional to acceleration due to gravity. Okay. Likewise, variation of weight of an object when it is carried from equator to the pole of the earth. First of all, variation of the weight due to change in acceleration due to gravity. Next one, variation of weight of the object when it is carried from equator to the pole of the earth. As you know, the earth is not perfectly spherical. Polar radius of the earth is comparatively less than the equatorial radius of the earth. Okay. The polar radius of the earth is comparatively less than the equatorial radius of the earth. As there is less radius in the polar region, acceleration due to gravity is more. As you know, acceleration due to gravity is inversely proportional to the square of the radius of the earth. Okay, acceleration due to gravity of the earth at the pole is 9.83 meter per second square. Okay. Acceleration due to gravity of the earth at pole is 9.83 meter per second square, is greater than that at the equator of the earth, that is 9.78 meter per second square. You need to remember this data. Okay, acceleration due to gravity at pole 9.83 and equator 9.78. Here 78 at the equator and 83 at the pole. It means acceleration due to gravity is slightly more in the polar region. Average value of acceleration due to gravity, generally we use 9.8 meter per second square. Okay. The greater value of acceleration due to gravity at the pole of the earth results in more weight of an object, as acceleration due to gravity is directly proportional to the weight, that is W is equal to mg. Variation of weight of an object when it is carried from earth to moon. Another term, variation of weight of an object when it is carried from earth to moon. What will happen? Okay, if the object having 6 Newton weight on the surface of the earth, what is the weight of the same object at the moon? That is the question. Okay, listen. The average acceleration due to gravity on the surface of the earth is 9.8 meter per second square. Average, okay, it is the average value. Average acceleration due to gravity on the surface of the earth is 9.8 meter per second square. And on the surface of the moon is what? Gm, that is acceleration due to gravity on the moon, is 1 by 6th part of Ge, that is acceleration due to gravity of the earth. Okay, Gm is equal to what? 1 by 6th part of acceleration due to gravity of the earth. Okay, listen. Acceleration due to gravity of the moon is 1 by 6th part of acceleration due to gravity of the earth. As a result, weight of the object becomes about 6 times less when it is carried from earth to the moon. Okay, if the object having suppose 60 Newton, okay, if the object having weight 60 Newton on the surface of the earth becomes only 6 Newton on the surface of the moon, 6 times less. Weight of the object becomes about 6 times less when it is carried from earth to the moon. So it becomes easy to lift the heavy mass on the moon. Okay, so it becomes what? Easy to lift the heavy mass on the moon because there is less acceleration due to gravity. So the person when jumps 1 meter on the surface of the moon can jump 6 meter on the surface of the moon. Sorry, when the person can jump 1 meter on the surface of the earth, okay, here earth should be there, can jump 6 meter on the surface of the moon, and the person who can lift 50 kg on the surface of the moon can lift about 300 kg. The person who can lift 50 kg on the surface of the earth, okay, surface of the earth can lift about 300 kg on the surface of the moon. 300 kg on the surface of the moon. Write down one question related to this topic. A man can lift 100 kg. Write down one question related to this topic. A man can lift 100 kg on the surface of the earth. How much mass can he lift on the surface of the moon? A man can lift 100 kg on the surface of the earth. How much mass can he lift on the surface of the moon? As you know, acceleration due to gravity on the moon is 6 times less than the acceleration due to gravity on the earth. That's why a man can lift 6 times more mass on the surface of the moon. It means about 600 kg on the surface of the moon. But we have to show it by calculation. Okay? But we have to show it by calculation. First of all, solution. Given mass lifted on the moon ME is equal to 100 kg. Okay, that is given. Acceleration due to gravity on the earth G is equal to 9.8 meter per second square. Likewise, acceleration due to gravity on the moon GM is equal to 1.63 meter per second square. Okay, it means 6 times less. Acceleration due to gravity on the earth 9.8 meter per second square. Acceleration due to gravity on the moon 6 times less. That's why only 1.63 meter per second square. Then mass lifted on the moon MM is equal to what? Here the weight lifting capacity of a man remains the same on the earth and on the moon. Okay, weight lifting capacity of man remains the same on the surface of the earth and the surface of the moon. That's why weight lifted on the moon is equal to weight lifted on the earth. Weight lifted on the moon is equal to weight lifted on the earth. That is, what is the formula of weight? mg is equal to mg. mm into gm is equal to me into ge, where m means m means moon, okay, e means earth, means mass in moon, gm means acceleration due to gravity of moon. Or by using formula capital M small m is equal to me into ge by gm is equal to 100 into 9.8 by 1.63 is equal to 601.22 kg. Therefore, mass that can be lifted on the moon is 601.22 kg. Okay, now write down some homework. A number. If the mass of a body is 10 kg and 10 kg, what is its weight on the earth's surface and the moon surface? If the mass of a body is 10 kg, what is its weight on the earth's surface and moon surface? B number. Mount Everest is 8,848 meters above the sea level. Find the acceleration due to gravity at this height. The value of acceleration due to gravity at the earth's surface is 9.8 meter per second square and radius is 64 kilometer. Another question. Two spheres of equal masses are placed at a distance of 100 meters from their centers. If the gravitational force of attraction between them is 1575 Newton, calculate the masses of each sphere. Okay, this was for today. Thank you, dear students, for watching. Next class, force, another part.